Introduction: Navigating the World of Backend Query Systems. Welcome to Mastering Backend Query Systems, a guide that opens the door to the intricate world of data management and manipulation. Whether you're a budding coder, a seasoned developer, a curious student, or a dedicated professor, this book is designed to illuminate the path of backend querying, filtering, and sorting, making complex topics accessible and engaging. Chatter. Why backend query systems matter. Imagine you're browsing your favorite streaming service, searching for the latest sci-fi movies, or sorting through a playlist of your top hits. Ever wondered what happens behind the scenes when you hit search or apply a filter? That's where backend query systems come into play. Backend queries are the unsung heroes of digital experiences. They're the algorithms and processes that take your inputs, understand your requests, and fetch the exact data you need, all while making sure the system runs smoothly and efficiently. What you'll discover in this book. In this book, we'll embark on an exciting journey through the world of backend queries. Here's a sneak peek of what's in store. 1. The anatomy of queries. We'll break down how queries work from basic to advanced, showing you how to craft precise questions to get the answers you need. 2. Filtering and sorting. Learn the art of narrowing down and organizing data. Filters refine results, and sorting arranges them in meaningful ways. 3. Real-time data updates. Discover how to keep your applications fresh with live data, ensuring users get the most current information without lifting a finger. 4. Handling errors. Explore strategies to manage and recover from errors gracefully, ensuring a smooth user experience even when things go wrong. 5. Scalability and performance. Prepare for growth and optimize your backend to handle increasing traffic and data demands. 6. Security. Understand how to protect your data and control access with robust authentication and authorization mechanisms. 7. Monitoring and logging. Keep track of your system's health and performance with effective logging and monitoring practices. 8. Testing and debugging. Learn how to ensure your system works as expected with comprehensive testing and debugging techniques. Why this book is different. We're not just diving into theory. We're making this practical and fun. Each chapter is filled with real-world examples, hands-on exercises, and engaging explanations designed to make learning both enjoyable and effective. Think of this book as your interactive guide to understanding and mastering the back-end world. Who should read this book? Students. Whether you're studying computer science or just curious about back-end systems, this book will give you a solid foundation and practical tools. For those already coding, this book will enhance your understanding and help you tackle more complex data challenges. Professors and teachers, use this book as a resource for teaching back-end concepts in a way that's accessible and engaging for your students. Tech enthusiasts, if you're fascinated by how technology works and eager to understand the back-end mechanics, this book is for you. How to use this book. Follow the chapters sequentially. Each chapter builds on the previous one, providing a structured learning path. Engage with hands-on exercises. Apply what you've learned through practical exercises and real-world examples. Explore further. Dive deeper into topics that interest you with additional resources and advanced concepts provided throughout the book. Let's get started. Ready to unravel the mysteries of backend queries and transform your understanding of data management? Let's dive in and start exploring how the magic of backend systems works and how you can harness it to create powerful, efficient, and engaging applications. Welcome aboard, and let's embark on this exciting journey into the heart of backend data management. Chapter 1, the backend magic, how it all works. Welcome to Chapter 1 of Mastering Backend Query Systems. In this chapter, we're going to peel back the curtain on the back end of applications, uncovering the magic behind how queries work and revealing the role of filtering and sorting. Ready to dive into the backstage world of data handling? Let's go. 1.1, the anatomy of a backend query. Imagine you're at a restaurant and you've just ordered a delicious pizza. When you place your order, you don't just ask for food, you specify what kind of pizza you want. Similarly, when you interact with an application, you're not just asking for data, You're making a specific request. This is where queries come into play. Task 1.1.1, what is a query? A query is like a question you ask a database to retrieve or manipulate data. It specifies what information you want and, in some cases, how you want it to be processed. Example scenario. Suppose you're using a movie database and you want to find movies released after 2020 with a rating higher than 8. Your query would look something like this. SQL select from movies where release year 2020 and rating 8. This SQL statement is asking the database to select all columns from the movies table where the release year is greater than 2020 and the rating is greater than 8. In NoSQL databases, for databases like Firebase Firestore, the query might be more abstract. JavaScript const query equals firestore.collectionMovies, where release year 2020 dot where rating John 8. And at 1.1.2, how queries work. When you send a query to a database, the following steps occur. 1. Parsing. The database interprets the query and understands what data you're asking for. 2. Optimization. The database decides the most efficient way to execute the query. 3. Execution. The database retrieves or manipulates the data as requested. 4. Result. The database sends the result back to you. Visualizing the process. 1. You ask, show me all sci-fi movies released in the last 5 years. 2. Database parses. The system understands you're asking for sci-fi movies within a specific time frame. 3. Database optimizes. It decides the best way to fetch this data, perhaps using indexes. 4. Database executes. It queries the data and retrieves the relevant movies. 5. You get results. The movies appear on your screen, ready to be browsed, on from code to user experience. The backend is like a skilled magician performing tricks behind the curtain. Users interact with the application without seeing the complexities of data retrieval, processing, and presentation. Here's how this magical process works. Deck 1.1 Code to Database. 1. Writing the query. Developers write queries in code to specify what data is needed. 2. Sending the request. The application sends this query to the database through an API or directly. 3. Database handling. The database processes the query and returns the data. Example in JavaScript. JavaScript /u/user wants to see recent high-rated movies const fetch movies equals async equals try const movies ref equals firestore.collectionMovies. Const query equals movies ref to where release year 2020 where rating 8. Const snapshot equals await query.get. Const movies equals snapshot.docs.map doc equals doc.data display movies. Function to display movies on UI. Catch error. Console.error, error fetching movies, error. Example in Dart Flutter. Dart future list movie fetch movies async. Try final movies ref equals firebase firestore.instance.collectionMovies. Final query equals movies ref where release year is greater than 2020, where rating is greater than 8. Final snapshot equals await query.get. Return snapshot.docs.map doc movie.fromFirestore doc.data to list. Catch E, print error fetching movies E, return. #SL 1.2.2 data to user interface. 1. Receiving data. The application receives the data from the database. 2. Processing data. Data may need to be processed or formatted. 3. Displaying data. The application presents the data to the user in a readable format. Displaying movies. In JavaScript, JavaScript const display movies equals const movie container its document.get element by ID movie container. Movie container.inner HTML movies.map movie.title movie rating div join. In Dart Flutter, Dart widget build movie list movie movies, return listview.builder item count movies.length item builder context index. Final movie equals movies index. 1. The backend magic, how it all works. Welcome. Chapter 2, Crafting Queries, the Art of Asking. Welcome to Chapter 2 of Mastering Backend Query Systems. In this chapter, we'll delve into the art and science of crafting effective queries. Think of this chapter as a masterclass in asking the right questions to get exactly what you need from your database. Ready to become a querying virtuoso? Let's dive in. 2.1, Constructing Effective Queries. Queries are like questions posed to a database. The precision of your query directly impacts the efficiency and relevance of the data you retrieve. Let's break down how to construct queries that get you the results you want, with examples and techniques you can apply immediately. 2.1.1 Basic Query Syntax. Whether you're using SQL or NoSQL databases, understanding the basic syntax is crucial. Let's start with SQL. SQL select shot from movies, where genre equals action, and release year, 2020, order by rating desk. Select from movies fetches all columns from the movies table. Where genre equals action, filters for movies where the genre is action. And release year 2020, further filters for movies released after 2020. Order by rating desk, sorts the results by rating in descending order. NoSQL example, Firestore. JavaScript const query equals firestore.collection movies dot where genre equals action where release year 2020 dot order by rating desk dot where genre equals action filters movies by genre dot where release 2020 adds a filter for the release year dot order by rating desk C orders the results by rating in descending order. That 2.1.2 Advanced Query Techniques. As you become more comfortable with basic queries, you'll want to explore advanced techniques to handle complex scenarios. Step 1. Combining multiple conditions. Use logical operators to combine multiple conditions. SQL example, SQL select from movies where genre equals action and release year 2020 or rating 8. Firestore example, JavaScript const query equals firestore.collection movies where genre equals action where release year 2020 where rating 8. 2. Using aggregations. Aggregate functions like count, avg, min, and max help summarize data. SQL example, SQL select genre